Let's look at permutations, where we have a number of items and the order we put them in matters, and combinations where the order doesn't matter. So let's look first at permutations. Permutations are counting the number of ways we can order a list of items. We use permutations when order is important. And permutations give us all the possible ways of doing something when we put things in a certain order. And permutations and combinations both involve multiplication. We're going to be multiplying the possibilities however many number of times we need it for the rank in the list. So N is the choices that we have, and R is the times we're going to actually use choices. Now there's really two forms of permutations. The first kind is when we allow repetition. If we can repeat something, and we have N choices, and we're going to choose R of them, then we're going to just multiply N by itself R number of times. And once we've got to that number R, we then have our answer. So another way to write that is N to the R power. Now where repetition is not allowed, we're going to choose the N items, and then for the first choice, and then we have N minus 1 of them left for the second rank, and then we have N minus 2 of them in the third rank, and so on until we get down to basically we've counted R of them. In other words, if I had 14 baseball players and I could get a roster of 9 of them at any given time, a batting order of them of 9 players, and I wanted to choose 9 out of 14, and the order was important because batting order is important, then I would choose 14 times 13 times 12, ... until I'd had 9 of those, and I'd multiply all those together. So calculating permutations involves multiplication. We're going to take those N possibilities and multiply them R number of times. If repetition is allowed, one example of that is like your locker combination, although combination, as we'll see, is a bad choice of word for that. And if repetition is not allowed, something like that would be like a batting order. Molina, Yadier Molina, much as we'd like him to go bat 9 times, he can't bat 9 times. He can only bat once. So we're going to take that ordered list of N items and ranking them. If repetition is allowed, we have N to the R power because we're taking N and multiplying it by itself R times. The more common use we're going to have for this is when repetition is not allowed, like the batting order question. And by the way, here's a couple of different ways to write permutations. We can write it as P, parentheses N comma R, or a little subscript N and then a P and then a subscript R, where N and R represent the number of items and the number of rankings we have for them. So that's actually 2 different ways to write permutations. So to calculate permutations where repetitions are not allowed, we're going to take N times N minus 1 times N minus 2 ... till we've gotten R of those things multiplied by each other. Now, factorial is a way to simplify that rather complex looking list there. And factorial would be, if you recall, it's N times N minus 1 times N minus 2 ... all the way down to 1. So 5 factorial, for example, would be 5 times 4 times 3 times 2 times 1. In simplified form, where repetition is not allowed, the formula for this is N factorial over N minus R factorial. Because what happens is N factorial and N minus R factorial, they will cancel out everything after the rth item. So let's look at a couple of examples. Let's take a typical 4-digit padlock, and each of those digits is one number from 0 to 9. Now the order of the numbers is important because it's, 1, 2, 3, 4 is not the same as 4, 3, 2, 1. Only one of them is going to unlock your padlock. So how many possibilities are there? How many possible permutations are there? There are 10 possibilities for each number because we can use the digits from 0 to 9. If we count all those, we get 10. Order is very important, and repetitions are possible. We can have 1, 1, 2, 3 as a possibility. And so the way to compute the number of possible permutations in this case, where there's 10 possibilities, order is important, and repetitions are possible, it's 10 permutations of 4. We're choosing 4 out of a list of 10. And it's really just n to the r factorial, 10 to the fourth, but you can write it as n times n times n times n. We have 4 of them. 10 to the fourth power is 10,000. So there are 10,000 possibilities on your padlock. That's going to take a while for someone to crack that, unless you put 0, 0, 0, 0 as your combination. Let's take a look at another example of permutations from the National League Central Division. There are 5 teams in the National League Central. What are the number of possible orders of first, second, and third place teams at the end of the season? Well, there's 5 possibilities for each rank. Although many of us would argue that the Cardinals will always be first place, there are nevertheless 5 possibilities. Order is important. First place is definitely different from second and third place. And repetition is not possible. You can only be in one of the positions. So let's compute that. So we're talking about a list of 5, and we're picking 3 of them to go in a certain rank, so we're going to use permutations. And that's going to be equal to 5 factorial over 5 minus 3 factorial. In other words, 5 factorial over 2 factorial. And if you don't have access to a calculator in the permutation button, the easiest way to do that is just write that out. 5 times 4 times 3 times 2 times 1 is 5 factorial. And then 2 factorial is just 2 times 1. And notice the 2 times 1, they'll cancel each other out, and we're left with 5 times 4 times 3, or 60. In other words, there are 60 possibilities for rankings of the 5 teams in the National League Central Division if we're talking about just first, second, and third place. Now let's transition over and look at combinations. Now, combinations are how we count possibilities when order doesn't matter. It gets rid of the repetition when it doesn't matter about the order. In other words, if 1, 2, 3 and 3, 2, 1 really are the same thing, we would use combinations. And interestingly enough, it's the same formula, it's the same idea as permutations, but it gets rid of those repetitions. So we're talking now, instead of n-ordered possibilities of our rankings, we're talking about n unordered possibilities. N is the number of items or choices, R is the number of things that we're going to pick. So let's take a tasty example here. 31 flavors from Baskin-Robbins ice cream, choosing 3 scoops. Now there's 2 possibilities here. There's two breakdowns. We can have repetition being allowed. In other words, if I really like chocolate, by the way, my favorite is mint chocolate chip, but if I wanted to choose 3 scoops of chocolate, that would be okay if repetition were allowed. Now that formula is a little bit more complicated. I'm going to give you the formula, but deriving it is really beyond the scope of this course. What we're going to use more frequently is where repetition is not allowed. In other words, I can't have chocolate, chocolate, chocolate. Okay, so combination is unordered items choosing R. In other words, N choose R. And there's really, by the way, this top part is the formula for where repetitions are allowed. It adds a little possibility when you can choose something multiple times, like chocolate, 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 it's going to make a slightly larger number, and that's where that addition comes from. We're going to focus on what's the bottom of the screen here, though, and that's the number of combinations where we choose R of them. Now, interestingly enough, the binomial theorem, Pascal's triangle, also uses this pretty heavily, and it's also written as this, parentheses N over R, parentheses. So these are just ways to write combinations where order does not matter. If repetitions are not allowed, you'll notice this left-hand part of this formula is really exactly the same as permutations. The only new part is this R factorial in the denominator. And what that's doing is getting rid of the repetitions. If order doesn't matter, vanilla strawberry chocolate is the same as chocolate strawberry vanilla. So we want to not count those things over and over again if they're the same, really, and order didn't matter. So that's where that R factorial in the denominator comes from. So if you remember, the combination formula is really exactly the same as the permutation formula, just with that additional denominator of R factorial to get rid of double and possibly triple or more counting. Let's look at a tasty example. Baskin-Robbins ice cream, 31 flavors of ice cream. And you want to have 3 scoops of ice cream with no scoops being the same. So how many possible combinations of Baskin-Robbins ice cream could you get if you were going to pick 3 scoops from their sample of 31? So let's look at the facts here. We have 31 flavors. Order does not matter. Again, Repetitions, unfortunately, are not possible. When we look at the formula for that, we're talking about 31 possibilities. We're picking 3. So a couple of different ways to write that. So it's going to be 31 factorial over 31 minus 3 factorial. Also in the denominator, that 3 factorial to get rid of the repetitions. So the answer actually simplifies down to 31 times 30 times 29 over 3 times 2 times 1. And that yields a delicious 4,495 combinations of 31 flavors if we're getting 3 scoops, all of them different. One of the important things about using permutation and combinations is to know which to use. The big difference is if you need to rank these items that you're working with and the order is important, you need to use permutations. In other words, ABC is different from CBA. 1, 2, 3 is different from 3, 2, 1. Permutation lists all the possible ways of doing something. Combinations, on the other hand, we're dealing with a list of things, but we don't care what order they're in. So in that case, we have to eliminate things that are redundant because ABC is the same as CBA. 1, 2, 3 is the same as 3, 2, 1. Hopefully you've seen in here a development of the idea of permutations and combinations, how we can use them to find the number of possibilities of things, whether they're in order for permutations or we don't care about the order for combinations.